Hello my friend, so now we are going to cover the chapter 2, which is called System Overview of the KNX Basic course. Here we want to start to know how to program the KNX devices in ETS, and we will learn some fundamental of the KNX. First of all, the book is going to provide us two concepts, the individual address and group address. From now on, you should learn what is the differences between two addressing, individual address or physical address and group address that contains group object or communication objects. Individual address or physical address is the unique address that each device in KNX will be assigned to, and the group address is some address that we use to link between sensor, actuator, and controller. In the next page, there is a minimum structure of the KNX TP installation. You can see the power supply unit plus choke that imports the 230 volt AC and provide us with the KNX power supply, and then we have the sensor and actuator. This sensor can be the push button. When you press the push button, the telegram or packet of data is generated here, and it's come to broadcast. And this actuator, because the group address is in destination, it's received, executed, and the relay, which was the normally open, is closed and the lamp will be on. So the book said this minimum structure include the power supply plus choke, the sensor that is single push button, the actuator that is digital output, and the bus cable that with the wire of the red and black provide us the power between 21 to 30 volts DC to power up the bus coupling unit of the devices in KNX and provide us the transmission of the data on the same wire. So next page, you can see we are going to assign these addresses that we talk about it later. Each device here is assigned with individual address 1.1.1 for sensor, that is push button, and 1.1.2 for the actuator. So they are unique and they are not the same. And we have the group address 5266 that is the same for both of these because they are linked to each other in this group address 5266 with their own group objects. And when you press this button, because the destination address is this group address 5266, this light will be on. Remember that the power supply do not get any individual or physical address. Of course, nowadays some power supply units are coming with troubleshooting options. They need to be assigned with some address. But here you can see there is no need for individual address for these power supply units. Okay, in the next page you can see the structure of the individual or physical address. Later, in the future, I will show you the detail of the physical address structure in topology chapter. But here you can see the individual address include three parts: area, line, bus device. Area can be between 0 to 15, line can be 0 to 15, and bus device can be 0 to 255. So, the next fact is when you want to assign some individual address to the device in S-mode devices, you need to have the PC with ETS installed on it and some interface like USB or IP interface connected to the system, and then you should press the programming button of the device. Your device can be the DIN rail device in electrical cabinet, there is a program button on it, or some sensor and keypad that Those also have their own power program button. You should find this program button, press it, and use the ETS to assign the individual address to the devices. About the group address, there's 3 types of structure for group address: 3-level, 2-level, and free structure. Of course, you are free to choose between those, but most of the time we use the 3-level structure because it provides us the better transparency in the project. It has the main part that is between 0 to 31 in ETS 5, middle 0 to 7, and the sub 0 to 255. We assign the main to the floor number of the building, the middle to the functionality. For example, you have the light control, HVAC control, shutter control, media or sound control, security control, and so on. So it has some limited. And then you assign the sub-functionality to sub-ones. For example, the first light, okay, in room number 1 from the floor number 1 is assigned to 1.1.1, okay? Yeah. So you can see the book is providing for us some key table. The main group you can assign to floor number. The middle one you can assign to functional domain like lighting, heating, shading, and the subgroup functional loader group of loads. But remember that this is some recommended options. You can assign these main and middle and sub to what you want, okay? It doesn't have any impact in your functionality of your project. It is only for your transparency, and because you should understand later what you have done, or maybe some other people can understand your systems much better. Yeah. You can see here the book is provide us these type of assignments here. The blue or main group address is assigned to ground floor, first floor, second floor, and the green one is assigned to lighting, heating, shading, and in lighting you can see the main light, living room, on off, for example. Okay, yeah, that is so interesting. So here I want to show where you can here you can see where you can assign this style of the group address. You can see this is a new project. When you create new project, you press this plus button. Here it is asked from you which group address style you want, the free, the 2-level, or 3-level, and then you can press the create the project. By default it is in 3-level, and for most of the time you can leave it in 3-level. Also later you can click 1 in each project, and from right hand side you can see the group address style here. Okay, you can also see it from here. Yeah. Okay, so now the book is providing for us some example. It says for each system the individual address in KNX is like the John Smith address. Okay, this is some similarity. The book wants to provide us more comprehensive example. Okay, the address of the John Smith that is written on an envelope, it says John Smith, for example, some street, some town, and this is unique in that city. So the individual address and physical address is unique in KNX system. Also, the group address, it's like the postal box of the John Smith. Sometimes the letter from tax company is coming, sometimes the letter of the school is coming, sometimes the letter of the John Smith office is coming. Okay, so different functionalities coming to the John Smith address. So it's like the group address. Okay, maybe you have the actuators with 8 output. You can use 1 output to switch light on off. You can use 2 output for control the shutter. You can use 4 output to control the fan coil with 2 pipe. So this combi actuator has the same one individual address, but it provides you different functionality that are connected to with the different group addresses. Yeah. The next concept is going to say the actuator in KNX can listen or react to several group addresses, but the sensor can, however, react to one group address, the first one. So, what it means? It means, for example, you have the several actuators in a electrical cabinet. Okay, you have the several actuators, for example, like here. You have the several group actuators, it's here, okay? So, these actuator, for example, can be stimuli or reacted with the different group addresses. For example, with group address 1 can be called from the first floor, with group address 2 can be called from the output of the timer, with group address 3. So this relay 1 of this actuator can react, can be assigned to different group addresses and react to all of them. Okay? But it is not the same for the sensor. In a sensor, for example, the keypad, you can see, for example, if I press this button, the A1 button of this sensor, I can turn on and off one light, okay? And if I have another on-off light, another relay actuator, and provide the second group address, and also I link this keypad, the A1, to that group address, and I press it, still the light 1 is on off and the light 2 is not reacting anymore. Okay, so each group object in a sensor is reacting to only the first group address it is assigned. If you make the second group address, it doesn't work anymore. Okay? So because of that, the book said, sensor can, however, send only one group address per telegram. Okay. Then the book said, for the main group address, the blue one, okay, between 14 to 31, for the old devices before 2003, they are not filtered in a line coupler or backbone couplers. Remember that. So the line coupler and backbone couplers with the older generation before 2003, they do not filter the group address between 14 to 31 because in ETS3 this blue one it's not 31, and later according to the needs it's increased, so they cannot filter it out. You should remember that, because it could negatively influence the dynamic of the entire bus systems. But for the new line coupler, IP router and so on, it doesn't exist any problem, and you can be assured that everything will be under the control. Yeah. Okay. And the number of group addresses that can be assigned to the sensor and actuator is variable, and it depends on the memory. If the memory is over, the ETS provide you the warning. Don't worry about it. Okay, about the configuration steps. First of all, you should create the project. You should create the project. For example, here, press it here. You should create the project. Make the name like the, you can say test number 1. Yeah. Press the create project and it will be created. You will be directed to the building part. For our sample, I choose the device because it is much easier than this. Then you can press the add devices. Add devices, the catalog is coming up. For the first time that you install the ETS, this catalog is empty. This is an online catalog. If you want to make it happen, you should go to ETS, press ETS, the setting, the online catalog, and put the market, for example, in Germany, and update it. So it will be updated with the latest devices. I use the KNX Association devices. It is for KNX Virtual. So here I am searching for KNX Association here, yeah. And I will choose the switching actuator here, yeah. Drag and drop from the catalog. I'm waiting, it is downloading. You can see the cloud here. This is the KNX cloud. I downloaded here and provided here. And also the clicks. This is a push button or sensor from KNX Virtual. Drag and drop also here. Okay, remember that in catalog there is an import section. If you cannot find your database here of the device, you should go to the website of the manufacturer and try to find the proper database, okay, and then download it from the website and import it here. For most of the discontinued devices, you cannot see the application program here. Okay, now I'm finishing the catalog. I close it, and then in the next step I'm going to assign the physical address. Okay, so I press on the device. From the right hand side in properties there is an individual address part. I put 1.1.1 and that's it. I assign it, and for clicks I do want to have some other one. 1.1, I choose 10th device, and that's it. So here there is a 1.1.1 and 1.1.10. Now the next part, we should go for parameterization. I press the switching from the parameter part. You can see here the setting part of this device. Always it is better to activate the highlight change because you can see what you have changed in compared to the default one. This is a channel 1 of this digital output. This is virtual digital output, of course. I press the channel 1. It has with no feedback, no alarm, no staircase, and it's really easy in KNX Virtual. From the device menu, from the group object menu, you can see there is a group object number 1 for channel 1 on off. Okay, so it is represents the control of the digital output or relay output of the channel 1 of this device. And for clicks or the keypad, virtual keypad, you can see the channel 1. In a channel 1, the functionality, you should Select which functionality you want because it provides you the right data point. This is switching with no feedback. It is fine for our example. And you can see in group object there is a channel 1 switching on off. That is done. So in the next step, I'm coming to the workspace and provide and open the new panel after the physical address, assigning the physical address and do the parameterization. We're going to the group address assignments. In a group address, I use the add main group address. For example, I say this is the floor 1, and then I'm coming here, add middle group address lights, and in a light I'm going to make some subgroup address. I say this is going to use for control switch on off of the channel 1. That's it. Okay, coming here. I'm coming to this group address. Now we should drag and drop between group objects. From the clicks, I drag and drop here, and from the switching, I drag and drop the channel 1. So in this group address, subgroup address, there's a link between these two. Yeah, great. Okay, here this is a KNX virtual. In KNX virtual, after you connect it, you should go to device topology here, yeah, and it is ready. Always you can figure it out if you are connected to the system or not, even in virtual. For this one, always you can go to the ETS bus part interface. You can see the interface part is here. Yeah, this is a virtual. In Discover, I'm going to connect it to the, in current, select it. Make sure that you are in the same area online. This is in 1.1255. I will provide you more detail in future. Press test. It is okay. This green okay. It means we are connected to the KNX virtual, and there will be no problem. Okay, we go to the project. Now there is no any green tick here. I choose it. Click right, download. I choose full download. It provides us the download for the physical address and application program. Yeah. Okay. Here, I want to download it to D7. So press the programming of the D7 of this virtual here. Yeah. Yeah, it is done. And the next one, the clicks, you can see these green ticks, so it shows it is completely downloaded. From here also, it asks us to press programming button of the D4 here, D4, and you can see if there is no any downloaded before, the physical address is 15.15.255. Remember that. So here I download both of them. You can see the screen here from the view base one. You can see this is the clicks or push button D4, and this is a D7. This is actuator. If I press 1, it is turned to light yellow light, and 0 1 0 1 0. Okay, so we can simulate the operation in KNX, the switching. You can see we create the project, import the database, import the devices, we assign the physical address, do the parameterization, do the group addressing, and downloading. We can reach the final destination. So here in a book it is said how it is done. I provide you the real example. Then if you want to control two lines, you need two group address. Each group address is for each functionality. If you want to control this light individually, you need its own group address. If you want to control this light individually also, you need its own group address too. So for group address 5266 in a book, you can control the channel A with the left rocker, and for 5267 you can control the channel B with the right rocker of the keypad. Yeah. So it is interesting. Then in a book it is mentioned that about the packet of data. The packet of data is contained control field, source address, destination address, routing counter, length of the useful data, and check byte. So the purple one that books focus on it is source address. Always our source address is a physical address of the devices. Remember that. For destination address, it is the group address in normal operation of the system. Okay, so the telegram is coming from the source to the destination, from the physical address to the group address. As a notification, I can send when you are downloading the program from the PC to the device, the destination address is physical address. And what is a useful data? If you want to control one light on off, the useful data is 1 bit 0 and 1. If you want to control the dimmer, like the light level between 0 to 100%, the useful data is 1 byte. If you want to transmit the amount of temperature, the useful data is 2 bytes. If you want to transmit the time, it's 4 bytes. If you want to transmit some text, for example in a hotel, you want to transmit the welcome to the room, it is 14 bytes. So between 1 bit to 14 byte, the useful data can be. And later in Telegram chapter in the advanced, you can see this can impact of the time of the transmission in the KNX between 20 milliseconds for 1 bit and 40 milliseconds for 14 bytes. So now the next concept is the data point times. Remember that in KNX, when you have the sensor from, for example, ABB, okay, and the actuators from Siemens, and you can connect these two to each other, the data point types are standard. I mean, the useful data are standard between two manufacturers. Okay, they can understand each other. So if some manufacturers use the 1.001 data point type to switch, the next manufacturer can understand it. So as the book said, several data point types were standardized to guarantee compatibility of similar devices from different manufacturers. Both the data format as well as the structure of the group objects, data format and structure of the group object, both for sensor and actuator function is part of the data point standardization. The combination of several standards data point type is called a functional block. The name of the group object can be freely decided by the manufacturers. So you can see, for example, here when we come to the group objects, this object function that is written channel 1 switching on off, this is for KNX association. It's not for everybody. Maybe in other devices it is different, but here when you press it of the device in properties, in data point type, you can see for switching there is a 1.001 switch in data type, so it is standardized and between all the manufacturers. So the name can be changed and whatsoever, but the data type is the same for all of them, all the manufacturers, of course. The name of the group object can be freely decided, and some data point types like scaling with 5.001 can be used for different functionality because this is some percentage. The amount of light is percentage, the amount of sound is percentage, the amount of opening of the valve is percentage, So these are so general data point types 5.001. For switching on off, you can see you can use the DPT switch, Boolean date or enable, disable. It is so easy. For shutter, you can see there's two type. You should use two type of data point types and make the functional block to make one shutter work. I will tell you later in other chapters. So one is for move and one is for stop, move, up, down, stop, and stop the blinds. So the combination of different data point types makes us the functional block to make some minimum functionality of the operation. And for dimming, that is the light level of the change the light level of the device, at least we should have 2 or 3 data point types. One data point type 1.001 for switching, the 4 bits 3.007 for relative dimming, and maybe in some cases 5.001 for absolute dimming. I will tell you later, don't worry about it. Then the book said about the group objects, 2-byte group objects that provide for transmission of temperature, brightness, wind speed, and so on. Sometimes in exam, in basic course, they will ask you these questions. You can bear in your, you can take it in your mind. Okay. So now we are going to talk about some interesting things. What is the interesting things we are going to talk about? So here you can see the destination in KNX. Always you should consider these these lengths. Yeah. So in KNX, each line segment can be extended until 1000 meter. Okay? You should consider that. For the device before the 2019, each line can consist 4 line segments, and in each line segment you can have 64 devices. So each line segment can be 1 kilometer, okay, or 1000 meters. But after 2019, you can have one line with 255 devices. Of course, the devices can support this type of topology, and that line can be extended until 1000 meter. Okay. Okay, and then in KNX, you cannot put the devices far from power supply plus choke. In the maximum, you can put it in 350 meters from the power supply and choke. Okay, so these devices should be near the power supply plus choke. In an installation part, I will mention you that after the installation you should measure the voltage of the devices that is far from the power supply and make sure that you have 21 volt DC at least. Then you can see the devices, the lengths between the devices should be maximum 700 meters, and you cannot put the devices far from each other. Yeah. So remember that. And in each line in KNX, maximum you can use 2 power supply units. Okay, and can you put these 2 power supply units right to each other without any distance? You should ask the manufacturers. Okay, if you don't know it, there is a minimum distance of 200 meters. So You cannot put it to each other. But for the new devices and power supply, for example, from the Siemens, you can put it to each other. Okay? Yeah. Okay, and what we should follow these lengths, because the book said you cannot put the devices far from each other, at least 700 meters. But why? In KNX we use the Courier sense multiply access with collision avoidance protocol to make sure that there is no any collision to the transmission of the data. So when the bus device 1 is sending, all of the bus device in a line are listening, listening until the bus device 1 execute its command. And when the bus is not busy anymore, the second devices, bus device 2 is sending. So there is some delay between the bus device 1 and bus device 2. So if you put the devices far from each other, this delay is not working anymore and the collision may be applied. Okay, so you should take care of 700 meters. The next fact is in KNX always we use the difference between the plus and minus. So if the noise is applied with the plus wire and also it is applied to the minus wire, and because we use the difference, this noise is compensated. Okay, so always we are noise free in KNX. So this is something good. And the next fact is in KNX, as we said, this plus this red and black wire, it provides us the power supply for bus coupling unit and transmission of the data. So how it is done? It is done by superimposing data on the wire. So here there is a power supply unit in KNX. Okay, so in each power supply unit, what will be happen? The power supply feeds the bus via the choke. A voltage regulator is included in a power supply which tries to immediately correct the deviation in 30 volt nominal voltage. If the installation were connected directly to the power supply, the voltage regulator will try to also correct the AC information voltage. This would result in tug of the war between the sending bus device and the regulator included in the power supply. Okay, so the power supply unit always wants to regulate the output voltage and keep it around 30 volt DC. But remember that in KNX, when we want to transmit data, we apply the -5 and +5 AC voltage superimpose in the DC voltage. So because once to regulate the voltage, it interferes the AC also. To avoid this, the choke is used to provide the inductance and inertia to the system. It allows the short-term deviation to the 30 volt voltage and at the same time allows the regulation of the DC supply voltage. So this is the task of the choke. So the second task of the choke is the generation of the second positive half of the AC voltage. Okay, so it provides us the positive half of the AC voltage. Only the first negative half is generated by the sending bus device. The cooperation between bus device and the choke result in an AC signal voltage without a DC part. So you cannot put the device far from the power supply unit plus choke because you will lose the data, because your data, the negative part is produced in bus coupling unit of each devices and the positive part is generated by the power supply unit. And this is important for the correct signal evaluation in the receiver. Okay. Also, in a book, it is said that because if you are far from the 1000 meter, because of the resistance, you will lose the data. Yeah, and you should below the 1000 meters. In my opinion, always try to have 20% as a saving. I mean, if it's 1000 meter the capacity of the cable, you should not exceed it more than 700 to 800 meter. Okay, it is safe. In this way, you will be in a safe side. If you can put 64 devices in one line, keep it between 40 and 50 devices, and use the line coupler or IP router and make another line. Yeah, that's it. Thank you so much to listen to chapter 2, and if you have any question, please ask me through the email or WhatsApp. Thank you so much. Have a nice day.